So now we're going to focus on using 4.6 volts to power a 555 timer in monostable mode, as you can see right here. So 14.6 volts is higher than usually you work with when wiring circuit. So blue LED is pretty straightforward. With a 2200 ohm resistor, we're going to get enough current. You can see it's really bright right there. The total current is about 12 milliamps of current for the entire circuit. But in any case, we have the red LED. So 1000 ohm resistor would be nice, but at this voltage, that's more wattage than I want to put. Make a 1000 watt resistor dissipate. So you can see at the output, we actually have a 470 and a 470, which is almost 1000 ohms, good enough, protecting the red LED. But since two of them are in series, they're going to split up the voltage in half, and thus they only get about half as hot as a single 1000 ohm resistor would get. So now we come to the schematic of my 555 timer monostable mode that is being powered with 14.6 volts. So that's kind of high voltage for basic circuitry. So we kind of want high value resistors, which is really easy for the pull-up resistor, for the trigger pin right there, and the timing resistor. You always just can use a lower value capacitor, higher value resistor. Very easy to limit current over there. It's the load that's kind of an issue. So we got a red LED we want to light up. Blue LED gets plenty bright. We could even use more resistance than that. But I'd like to use a 1000 ohm resistor, but that would get too hot when you got 14.6 volts powering this. And so instead I got two resistors that are about half the value, but they're in series, so their resistances add up. So you get about the same resistance, but each resistor is going to get about half as hot. So that's my solution for protecting the red LED. So now I designed this circuit a long time ago. It's a 555 timer monostable mode, and it's being powered by 14.6 volts right there. And so there's a couple things that I made to address that issue. When it comes to the timing, the supply voltage doesn't really matter. It's the value of that resistor and capacitor. So for making short videos, which I'm mostly doing now, that's kind of a long time, about 5 seconds to do this. So it's 470,000 ohm resistor. If I use a 100,000 ohm resistor, that's, about a fifth of the value right there. And so we're going to get about a fifth of the amount of time the output's going to be high. So now it's about a second. So it's that easy to adjust timing. If it's taken twice as long as what you want, you could either go like half the value of the capacitor or half the value of the resistor, and you'll get half the time that you were getting before. So now I'll use the schematic diagram to explain what we did. So I got the 555 timer in monostable mode, and we're working with 14.6 volts, the max of a charging 12 volt lithium iron phosphate battery. So mostly we just had to worry about the resistor values protecting the LEDs, and the red LED, since we kind of want a low resistance for this, I doubled up the resistors, but we're not going to focus on that too much now. I have the timing set up here where it's going to be about 5 seconds approximately that the output will be high when we press the button. And I wanted to cut that into like a fifth, make it about a second. All I did was yank that 470 ohm resistor, put a 100K resistor. Then every time I hit the button, the output was high for about 1 second. So it's that easy to adjust the timing. Get used to that. Don't get used to having to always use the values you see on there. These two especially are meant to be adjusted as much as possible.